All right, so last section here is logical equivalence, tautologies, and contradictions. So first of all, logically equivalent, two statements are logically equivalent if they have the same truth value under all circumstances. So for example, an implication and its contrapositive would be logically equivalent, as well as the inverse and the converse of an implication. Tautology is a statement that is always true under any circumstances. So for example, if P, then P, of course, if it's going to be true no matter what. If a statement is a tautology, then it is considered to be logically valid. A valid argument is always true, thus, again, a tautology. An invalid argument is not always true. So if you're asked to say whether a statement is logically valid, if it's always true, it's logically valid. If it's not, then it's invalid. And again, another word for a valid argument is a tautology. And then finally, a contradiction. A contradiction is a statement is a contradiction if it is always false under any circumstances. So for example, if not P, then P, that's of course going to be false. So tautology is if it's always true. Contradiction is if it's always false. If it's a combination of both, there's not a name for that. So show that not P, or and if not P, then P then Q is a tautology. Okay, so using our two tables from a few days ago, we're going to fill this in here. So first of all, we've got our not P, which is of course pretty easy to do here. So that's going to be false, false, true, and then true. If P, then Q. Let me see here if I can bring this. There we go. Okay. So if P, then Q. So we're looking here for our P and Q. So we've got, we're ignoring that not P. We'll need that in a minute. True and true is a true. True and false is a false. False and true is a true. And false is a true. Then we're going to do these two and do the same thing. So we have a false and a true. That's going to be a true. A false and a false is a true. A true and a true is a true. And a true and a true is a true. So we were supposed to be showing that this is a tautology. We have done that because since the last column is all true, and look, I had that down there already for you. So it is a tautology. Okay. All right. Another type of example here. We don't really need our truth table for that. Sorry. So we can put this up here. So part A of this example, P says that it is cold, Q is the ice is thick, and R is I will go skating. So we're going to write this statement here in words. So we have P, conjunction Q, and then we have our double arrow R. So the conjunction is the same thing as an intersection, essentially the same thing as saying and. The double-sided arrow, that's my if and only if. So we actually need to put the if and only if in front. So if and only if, sorry, we're not going to say P. We actually know what P is. If and only if it is cold and Q, the ice is thick, then I will go skating. Okay, no big deal there. Now, use a truth table to test whether the statement is logically valid. So this is the statement that we just had a minute ago, and just so we can keep, just so we have an idea of of what we're talking about here, I'm going to go ahead and rewrite it. IFF, remember that means if and only if. I wouldn't use that on the exam, but you can use it for my test. If and only if it is cold and the ice is thick, then I will go skating. Okay, seems like a pretty good statement there. Okay, so this one, we've got a P, Q, and an R, because obviously we had 3 statements there. So our first one, we're going to use our P conjunction Q, and that's my and. So here's our disjunction. Whoops, sorry about that. Okay, so we're ignoring the R. True and true is a true. Here's another true and true. True and false is a false. And here's another one. False and true is a false. Here's another one. False and false is a false. And there's another one. Okay, now we're going to do our if and only if. So now we're down here at the end. Again, on the test, I'm going to give you some truth tables that you can write on, that you can fold, whatever you want to do to try to make this a little bit easier. It's not difficult, it's just trying to keep everything straight. Now, in this case, we're going backwards, so that does make it a little bit more difficult, so we're reading it from right to left instead of left to right. If you wanted to put, go ahead and write your R's here, you could do that. Just kind of copy them over. I don't have a problem with that. As long as I can tell what your final answer is, that would be fine. Then you're not trying to go backwards. So let's actually do it that way, because that's actually a pretty good idea. Now let's make sure that we copied that column down correctly. Okay, so we're good. All right, so now we're just going to look at these things right here. Okay, so looking at my statement there. Okay, so this time we're kind of forgetting about all that stuff in the middle. So true and true is a true. I don't have other colors here right now, so we'll just do this in blue and just realize that, we'll do it. There we go. So true and true, that's going to be a true. We don't have any others of those. True and a false, that's going to be false. Don't have any others of those. False and a true, that's a false. And actually, if you want to jump down here, the only other true situation we're going to have, we have a true when it's true and true, which we've already done that. And then we have a true when it's false and false. So here's a true, here's a true, here's a true. Those other ones are going to be false. So by all means, if you can find a shortcut, do that. Otherwise, you can go step by step there. So we're trying to figure out if this statement is logically valid. So remember from the other side there, logically valid. We don't need our table here anymore. Logically valid means that it's going to be true for the entire thing. So since this column right here is not completely true, then that's going to be not logically valid. So test whether it's logically valid. It is not logically valid.
Princess Hayden and early form.
Okay, sorry about that. It is not logically valid because it is sometimes false. And you can word that however you want, but it has to be true every single time in order for it to be logically valid. Now, just a note here, this is not a contradiction. Because it is sometimes true. So my tautology, that's going to be only when it's entirely true. In the contradiction, that's when it's entirely false. Since this one is some of both, then it's not going to be a contradiction. So the notes are pretty short. I didn't really feel like I needed to go through more. This is kind of a little bit of a review section, but throwing in some new statements here. So again, as always, let me know what you have questions about. We'll start doing review in the next session here, and then we're all ready for the test.